Welcome to ZimCanIT. In this video, we're going to illustrate subnet peering. The architecture that we have in front of us showcases subnet peering, in which we have a web server workload, this VM IAS core, that is directly peered to two backend subnets, an integration subnet and a SQL backend subnet. All VMs deployed are standard Windows Server data center instances. However, the web server workload has the web server role configured through Server Manager. The entire infrastructure, as is displayed on the architecture diagram, is configured using Terraform. All of the code will be made available. There'll be a link in the description box below, coupled with deployment steps and additional documentation for further reading. Now, subnet peering builds on top of the concept of virtual network peering. So if we look at this diagram, to the left-hand side, we have a virtual network, the hub VNet 192.168.5.0 being its IP address range, and then our spoke virtual network 192.168.0.0 being its IP address range respectively. Now, VNet peering would essentially connects two virtual networks together, enabling workloads within subnets associated to each VNet to communicate to one another, so long as there is an NSG permitting for traffic to traverse to the next hop of a workload in another virtual network via the peering that's established. Within the context of this solution, we have two virtual networks in the same region, UK South, and we're peering our web server to our backend integration instance, which is a cloud backup VM, and our SQL backend. Now, we have an HSM backend, which is going to illustrate how subnet peering enables more granular connectivity between specified CIDR ranges. And we're going to test reaching our web server from our HSM backend, which will fail and is expected to fail. And in addition to that, we're going to test enabling connectivity from our integration server to our web server, as well as our SQL backend server to our web server, which will work, and it's expected to work. Now, let's take a look at the code, which is defined here. As always, the Git repo will be made accessible. Now, obviously, the deployment steps are to the right-hand side, but if we look at the code itself, especially the network configuration, we have our hub virtual network, our spoke virtual network, and then we define our peering. So from the hub to spoke and then spoke to hub. The core attributes to pay attention to here are the definitions of feature sets that are typically modified for the establishment of VNet peering. Now, bear in mind, when it comes to the deployment of subnet peering, there is no possibility of establishing subnet peering through the Azure portal as it stands. So we currently deploy subnet peering either via Terraform, the Azure CLI, ARM templates, PowerShell, things of that nature. There's no capability at this point in time to deploy subnet peering via the Azure portal. So this Terraform configuration states that for the hub to spoke peer, we're going to allow virtual network access. We're going to deny forwarded traffic because we're only peering two virtual networks. We don't have a gateway transit enabled, neither do we peer the entire virtual network address space or use a remote gateway. To enable subnet peering, all we need to do is explicitly specify the local subnet name and its mapping to remote subnet names that should be established. So within the context of our architecture, our IAS core-frontend should be peered to our integration backend and SQL backend subnets. Okay, so looking at the hub to spoke peer once again, we specify the name within the local subnet names variable, the name of our IAS core web front-end subnet, and then we specify the name of our remote backend subnets here. Then we just reverse the configuration with the spoke to hub, giving it its respective name, local subnet names being the SQL backend and integration backend subnets, and then the remote subnet being the IAS core front-end subnet. We have additional configuration files, bearing in mind we have our servers, a web extension, or virtual machine extension, I should say, that will enable the web server role, and we deploy our spoke instances iteratively with the resources being defined, notably their private IP addresses and names in a locals block. So if we look at the locals block, bear in mind these IP address ranges here. So The 192.168.0.4 is for our SQL backend instance. We've got 192.168.0.20 for our backup instance, which is within the integration subnet, and then the biz reports VM ending in 0.36 or 0.36 being deployed within the HSM backend subnet. So we're primarily going to test connectivity from these IP address ranges to our IAS server. Now, the IP address of the IAS server is specified on the NIC resource, which is there we go, as a variable, right? So var.iasnic private IP. So if we look at our variables.tf, we have the IP address of 192.168.5.4. That's the IP address which will be used to launch the web server, the IIS web server or web page, once the resources defined in Terraform have been configured. Now, simply put, deployment-wise, you want to log in via the Azure CLI, AZ login, account set, for your subscription context, validate that. You want to register this specific feature here, and your desired output is stated as follows. We've already done that, so if you want to just validate that, just showcase the feature. By we, I mean I've already done that. Now, there you go. So it's already registered. There's nothing to do besides moving on to the next step. So we're going to initialize our configuration files. Okay. And in doing so, we're pulling all the resource providers that we need for this deployment. We're going to generate a Terraform plan file. And as we can see, we're going to provision 30 resources. Scrolling up, okay, we can see that, okay, we're going to deploy our SQL backend subnet. We're going to deploy our integration backend subnet, and all the resources listed within the architectural diagram we were looking at earlier on. So all that's left to do now is to apply the configuration, and this should take about 5 minutes or so. So I'm going to pause the video, and then we'll look at the deployed infrastructure in Azure, and then start testing connectivity. So our resources have been provisioned, the apply process is complete, and we've outputted the public IP, of which is associated to my laptop, I should say. So it's the router that my public IP, yikes. So the resources have been provisioned. Now we're going to head over to the Azure portal, and if we take a look, here's our resource group. Always reference the architectural diagram after deploying your configurations, just to validate that you have everything that's specified. So let's start by taking a look at the public IPs that have been deployed per VM instance. You'll need these public IPs here on the right hand side to RDP onto your respective instances, from the IIS server to the SQL backend instance. And the reason as to why the public IP of the laptop that has deployed the infrastructure, or the computer device that has deployed the infrastructure, is outputted, is so that you know it's whitelisted for the security rules defined in security.tf. So notably for inbound RDP access, we allow solely RDP from our public IP. So whatever your public IP shall be. There you go. So those are our public IPs. Let's take a look at something that made me scratch my head at the initial deployment phase. So the biz reports network interface card is associated to the HSM backend subnet. Okay. Now there is no direct peer, or there shouldn't be, I should say, connectivity from the HSM workload, the biz reports VM instance, to our snet-iiscore-frontend instance. However, when I was looking at the network interface card for this biz reports instance and looking at its effective routes, I noticed something rather interesting. Okay, so bear in mind the private IP of our IAS server ends in 5.4. and is deployed within the IIScore-frontend subnet range. And that subnet range is 192.168.5.0. Going back to the isolated workload, 192.168.5.0/28 is actually listed on the effective routes. And I thought to myself, despite having explicitly set the local and remote subnets for the subnet peering to be established, why is this route being displayed? And essentially what's happening in Azure on the backend, or at least under the hood, is that subnet peering still remains at the virtual network level. So virtual network peering would occur by mapping the entire IP address range of your VNet. We are still achieving a similar function, wherein which peering is occurring at the VNet level. However, Azure will still propagate the subnet routes of the peering connection to all NICs within the peered VNet. And despite this routes propagation and route injection into the effective routes table, we do not have connectivity established because of the explicit local and remote subnet names that are defined within the peering definition, so within our code itself. So don't worry too much if you ever deploy subnet peering and notice that your effective routes for isolated subnet workloads contain the CIDR ranges of peered VNets. It's expected. Now, we're going to proceed to take a final look at the resource script that's been deployed. And within it, we've referenced the public IPs, the network interface cards. We can ignore the OS disks for now. These are our VM instances, and we're going to RDP onto those. However, let's take a look at the peering. On the hub virtual network, when you select that service and then go to the peering, obviously you can see our peering status is fully synchronized and connected, but we list the IP addresses here as 192.168.0.0/28, and there's an additional IP address that's listed. Now, we can't see it in the portal, but if we reference the README file of our code, from our code I should say, in order to show peering information, we run this here command, which will generate a text file known as vnethub.txt. And if we open that text file, we can then see the information about our deployed subnet peer. Now, that then shows the local subnet name, which was defined on our hub virtual network for the peer, which is our IIScore-frontend, and it defines the virtual network address space for the local subnet itself that's been referenced here, 192.168.5.0. And in addition to that, we then state our remote subnet names, which is our SQL-backend and our integration-backend, and their respective IPs. So remember how in the portal we saw 192.168.0.0. The additional CIDR range for our integration backend is 192.168.0.16, which can be validated by going into the portal, the Azure portal, going to our spoke virtual network, going to peerings, and in fact going to subnets. And we can see that here. So our integration backend 192.168.0.16. Cool. So subnet peering has been established. We've clarified the effective route configuration. You will then want to define your config within the remote desktop application. Within my instance, I'm using the mremote-ng, and we're going to connect to our IIS web server and our SQL backend instance, our cloud backup instance, and our business reporting instance. So we'll let that load. Okay, so I've enabled connectivity via RDP to all deployed instances. Let's take a look at the individual IPs of each instance. So obviously this is our IIS server, so we know it's going to end in 5.4, and evidently so, there is our private IP, 192.168.5.4, jumping back to the Azure portal, and we should see that for our IIS server's NIC, the private IP is 192.168.5.4. Now, let's take a look at the other instances. If we go to our SQL server, and then just run ipconfig, config. Again, 0.4. That's for our SQL backend. And if we take a look at our SQL NIC, 192.168.0.4. So it's very self-explanatory. We could do this for the other instances, but we want to test connectivity straight away. So from the IIS server, we're going to type 192.168.5.4 into the Edge browser, and that will launch our web page. Okay, so the extension defined via Terraform code that installs the web server role via Server Manager worked, and we can access our web page from our IIS server. Perfect. Looking back at the reference architecture, our integration backend contains a cloud backup instance that should have access to this web page in addition to our SQL backend. Now, navigating back to our SQL backend, if we just curl our site, HTTP 192.168.5.4, we're expecting a 200 status code. So we just fix that colon. There we go. And there you go. So grabbing the URL here, pasting it in to our Edge browser, and from our SQL backend instance, we can reach our IIS web server. From our cloud backup instance, again, just confirming its IP, 192.168.0.20. That's for our backup instance. And if we look at its NIC, for the backup instance, it's 192.168.0.20. Perfect. Should we be able to reach our IIS web server? Evidently so, and we can. From the biz reports instance, which despite having the route displayed on its effective route, can we reach this here web page? The answer should be no. Now, if we curl the site, we should have an error populate. And just looking at the routing whilst that command is running, bear in mind that there is no direct subnet peer between our business reporting instance within our HSN backend subnet, so an isolated network to our web server, which is as expected, right? So from a business use case perspective, subnet peering enables granular security given that you're not mapping your entire virtual network address range. Instead, you're mapping isolated networks on an as-needed basis, so it's much more granular from a security perspective. Now, navigating back to our isolated instance, and we can see that we were unable to directly connect to our IIS server instance. And that's subnet peering in a nutshell. So clone the GitHub repo associated with this here code deployment, navigate into, and just follow the deployment steps, and have fun. As always, happy learning, and thanks for watching this video.